For the Module 5, Lesson 8 problem set, we're going to look at finding equivalent fractions through multiplication. So in the directions it says each rectangle represents one. The shaded fractions have been decomposed into smaller units. The expression of equivalent fractions in number sentence using multiplication. The first one has been done for you. So here, when you look at this imagery, this graphic source, you have columns, and you have 3 of them, okay? 3 of the columns, where 2 of the 3 are shaded, and that's what we see here in the fraction 2/3. But what we did is we actually drew a line through the middle of it to show the same amount of space is still in that location, but I can also look at it in smaller pieces. Same amount, just in more smaller pieces. So in this case, I have 2/3, or if I look at this as smaller pieces, I have a total of 1, 2, 3, 4, 5, 6 pieces, with 4 out of the 6 included. And we can look at this by increasing by 2, right? I cut in half, or I increase by 2. So the 2/3 times 2 would get to 4, and 3 times 2 would equal 6. We increase both by times 2. And a huge thing for finding equivalent fractions is you increase both the numerator and denominator by the same amount. Now in this fraction, if we look at those same columns, right, we have 1, 2, 3, 4. We have 4 total columns with 3 of them shaded. And in the end, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, a denominator of 12, and the amount shaded would be 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 out of 12 shaded. The amount shaded did not change. I just broke those 3/4 into smaller pieces, making it into 9/12. And so you ask yourself, how did I get from 3/4 into 9/12? Well, I broke it by 3. I increased by 3. So 3/4 times 3 and 4 times 3 would get us to the 9/12. We increase both by times 3. In a problem like this, we had 1, 2, 3, 4, 5, 6 columns with 5 of them shaded. And when I increased them into groups of 2, times 2 and times 2, 5 times 2 is 10, 6 times 2 is 12, and let's see if that's accurate. We have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 total pieces with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 shaded, so that is accurate. In a problem like below, it's going to ask us to decompose into the given amount. So right now I have 1, 2, 3, 4, 5. I have a denominator of 5 with 3 shaded. And it wants me to decompose into tenths. How do I get from 5 to 10? Well, I'd have to multiply by 2. And if I multiplied by 2 down here, I'm going to have to multiply my numerator by 2, which would equal 6/10. And when I draw a line to make it into tenths, I will count 1, 2, 3, 4, 5, 6 shaded, 6, 7, 8, 9, 10, 10 total pieces. For the next set, you're going to create area models to represent these number sentences to be true. So for instance, let's look at this 3/6 to 6/12. So 1, 2, 3, 4, 5, 6, and I'm going to shade in 3 of them. And now, if I try to go from 6 to 12, I know that it's double the amount. So if I cut it in half, I now have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 12 total pieces, and I have 6 of them shaded. And all I had to do was break it in half. I increased both the numerator and the denominator by 12. In 4, it's going to ask us to find an equivalent fraction. It doesn't much matter which way we do it, but let's look at C. We remember that whatever we multiply the numerator by, we also have to multiply the denominator. So say I wanted to do this 7, 6, increased by, I don't know, 8. Well, 6 times 8 would be 48. 7 times 8 would be 56. We could do a large one, multiplying both by times 8. I could do it as simple as times 2, where 7 times 2 would equal 14, and 6 times 2 would equal 12. So 14/12 is the same thing as 7/6, which is the same thing as 56/48. And what you'll learn is we're going to adjust the denominator to use it how we need it. For instance, if I'm talking about the number of students in my classroom, I'm going to want it to be 18. I have 18 learners in my room. If I'm talking about the number of members of my family, I would want the denominator to be 5. So you need to just adjust the fraction in both ways, both the numerator and denominator increasing or decreasing by the same amount. Okay? And the last one, by doing multiplication, you're going to check to see if they're correct. So you'll take one of them, for instance, this 4/5 to 12/10. Well, 4 times 3 gets us to 12. 5 times 3 does not equal 10. So this one would be not correct. Okay? Because it would either have to be 4 to 12 times 3, 5 to 15, or it would have to be 5 to 10 by times 2, so this 4 would be 8.